So in the broadside array case here, you know the equation here. What is the equation? Electric field equation you know here. What is the equation? E is equal to something called as a sine of n psi by 2 divided by sine of the psi by 2 here. Okay. So in this total electric field here from the n etc point sources here, what you have to do here is we have to get the pattern maxima here. So to get the pattern maxima, what we have to do here is sine n psi by 2 is equal to 0, 1 here, right? So this equation that is you are seeing here, sine n psi by 2 is equal to 0. Sorry, it is equal to 1 here. Okay, so this is what is minor lobe maxima here. We are trying to find out the minor lobe maxima here. Right? We will be having three here. It is major lobe, minor lobe, and null directions here, right? So major lobe we have already found out that is maximum direction here. In the broadside array case, maximum direction will be what here? Perpendicular to the axis of the array here. Then now we have to find out the directions here where these minor lobe maxima are there here, right? So to find out the minor lobe maxima, this is sine of something. Sine of something is nothing but here n psi by 2 should be equal to 1 here. We have to. So if at all I wanted to make this parameter, this term here, that is n psi by 2 is equal to some value here, so that sine of this n psi by is equal to 1 here. So what you have to place here? Plus or minus 2k plus 1. Okay, that is pi by 2 here. That is sine of 90 is equal to 0 here, right? So that's why n psi by 2 is equal to plus or minus 2k plus 1 into pi by 2 here. Let us substitute the value of k here. K is equal to, if at all, for example, let us substitute the value of k here. K is equal to 0. If you substitute here, what will be the value here? 2 into 0 is nothing but here 0. 0 plus 1 is 1. Okay, so 1 into pi by 2 is pi by 2 here. Okay, so if at all, instead of n psi by 2, if we substitute the value of this particular term as 90 here, in this case, what is going to happen? Sin 90 is equal to 1 here, right? So you know the value, right? Now, what is the value of psi here? Psi is nothing but a total phase difference, as I written in this case here. See here, psi is equal to beta d cos phi plus delta of that. So in the broadside array case here, delta is equal to 0. That is phase difference is equal to 0. There is no phase difference. Okay, between the adjacent sources here. So that's why delta is equal to 0 means psi is equal to bd cos phi here. Now substitute the same thing, bd cos phi here. So we will get is equal to plus or minus 2k plus 1. Pi is there here, right? So there was some term plus 2 here. This 2 term in the RHS side and this 2 term in the LHS side will get cancels here. And whatever the n term will there will be coming towards the RHS side here. So finally we will be having cos phi is equal to plus or minus 2k plus 1 pi divided by n beta d here. Okay? This is the final equation which we are having here, right? So now in this term here, cos phi here, let us take the value as n is equal to 4, n is equal to 4, and d is equal to pi by 2. N is equal to 4 and nothing but here we are having 4 isotropic point sources here. 1, 2, 3, 4, 4 isotropic point sources there, and the distance between the these sources will be lambda by 2 here, right? The minimum distance we are going to consider. Suppose if you are substituting this particular value 4 and d is equal to lambda by 2, and you know the beta value here. Beta value is, what is beta value? There is 2 pi by lambda here. If at all we substitute these three values here, n, d, and beta here, what will be the final value? N is equal to 4 means we have to substitute 4 here, 2 pi by lambda and lambda by 2. Lambda get cancels here, pi get cancels, 2 get cancels, and final answer will be cos phi is equal to, what we will have here? Cos phi is equal to plus or minus 2k plus 1 divided by 4. Okay. Now let us substitute the value of k here. K is equal to 1. If at all you substitute the k is equal to 1 in this case here, so what we are having? Phi is equal to cos inverse of plus or minus 3 by 4. Okay, so plus or minus 3 by 4 is less than the one value here. So we will be having certain value we are going to get here, right? So 41.4 degree or 38.4. Okay, at this angle or at this particular direction here, we'll be having the minor lobe maxima here. Okay, that is plus or minus 41.4 and plus or minus the 138.4. We'll be having the minor lobe maxima here. In this particular direction, I will show in the figure in the next page here. Suppose if you put k is equal to 2, if at all you put k is equal to 2, 2 into 2, 4, 4 plus 1 is 5, 5 divided by 4, you will be having the value more than 1 here. So more than value, 1 is not a suitable value for the cos, sine, and the tan, this one, right? Tan, right? So what else? It is not a valid one here. 5 by 4 is not a valid. If at all we are having 4 by 5, then it is less than one value should be there here, right? Always cos for cos and tan and sin here. So now we have found out the direction of a pattern maxima here. Direction of pattern maxima, there is a minor globe maxima here. Now let us find out the direction of pattern minima here. Okay, so to find out this particular direction pattern of minima here, so what you have to do, in the previous case we have taken sine of something is equal to 1, right? Now we have to take sine of something is equal to 0. So when exactly the sine will be 0, right? The sine, how exactly the sine will be 0 here? Something multiple of this 180, okay? We will be having sine 0 and 180, okay? 360, okay? So these, it will be 0 here. So that's why n psi by 2 is equal to plus or minus of k pi here, okay? Right. So if at all you substitute this particular plus or minus of k pi in the place of n psi by 2, you will have sine of 90 here. Sorry, sine of something is equal to 0 here, right? So that's why again psi is equal to how much here? Plus or minus 2k pi divided by n here. You know the psi value beta d, okay? Beta d cos phi plus delta here. For the broadside array case, delta is equal to 0, okay? So beta d cos phi is equal to again plus or minus of 2k pi divided by n here. You can take this LHS term BD, sorry, beta d to the RHS denominator here. So you know, again let us consider there are four isotropic point sources here, and the distance between the adjacent point sources is equal to lambda by 2 here. Substituting the value, what you're going to get here, you're going to get plus or minus k by 2 here, right? So if at all you substitute the value of k is equal to 1, means plus or minus 1 by 2 cos inverse will be having plus or minus 60 or plus or minus 120 here. Again, k is equal to 2, if you substitute plus or minus 1 is there, will get either 0 or 180 degree here. K is equal to 3, if you substitute, you are having the value more than 1 here, then it is again not valid here, right? So this is how you are going to get the uh, pattern minima here. So what is the understanding here is plus or minus 60 or plus or minus 120 and 0 degree and 180 degree. Here we will be having the, what you can say, that direction of pattern minima. Direction of pattern minima is nothing but here your null directions here. Remember, null directions here, null directions where there is no radiation at all here, okay? That is null directions here. You can see in this particular figure here. So this is what is the phi is equal to 90 degree here. So phi is equal to 90 degree, will be having the pattern. This is what is the maximum radiation here, or max beam direction here. That is phi is equal to 90 degree here, okay? So this is what is in the right side of this one is pattern maxima here, that is 41.4 degree, and in the left side you are having pattern maxima also. This is pattern maxima, that is 138.6 degree. In the same way, minus 138 and minus 41.4 degree here. These are all the pattern maxima and maximum direction here, maximum beam direction here, okay? So you can say broadside array is maximum beam which is perpendicular to the axis of the array here, right? That is how you can say here, right? So what about this here? 0 degree or 180 degree plus or minus 60 and plus or minus 120 is nothing but here where there is no radiation here, okay? See here in the phi direction, phi is equal to 0 degrees, so there is no radiation at all here, right? Here also 180 degree, there is no radiation. That's why it is been, it is null direction where there is no radiation here. That means at a 60 degree between the 90 and 41 here, we will be having some 60 degree here. At this particular point, you will be having no radiation at all, or no no radiation here, no radiation region you can consider here, okay? This is how we can define regarding the pattern maxima and pattern minima here. Now let us understand another point concerned with the broadside array case here, that is beam width between first null here, okay? So this beam width between